Hello students, so in this video we're going to begin section 8.3 on testing the difference between means from dependent samples. So at the beginning of the section on page 437 you'll see some basic information about the hypothesis tests we will do in the section on the difference between two means from dependent samples. Okay, so some of the important information you want to highlight are the conditions necessary to conduct the hypothesis tests in this section. So there are three conditions here. Okay, and then likewise, the meaning of some of the symbols that are going to be used in this section, and in particular, you'll be asked about the meaning of D bar, okay, and the meaning of SD in one of the homework questions from this section. Okay, so before we begin the homework, let's go ahead and discuss the basic setup of the hypothesis tests in this section, including some of the important notation that you'll be using. Okay, so in this section, N will stand for the number of pairs of data. Okay, so remember you're working with two different samples. Okay, and since the samples are going to be dependent, each data value in one sample is paired with another data value in the other sample. Okay, so that's why the N stands for the number of pairs of data, right? So we're working with paired data. So samples that are dependent are often called paired. Okay, so N will stand for the number of pairs of data that you have. The symbol mu sub D or mu D is the mean of the differences between all paired data values in the population. Okay, D bar is the mean of the differences between the paired data values in your sample. And then SD is the standard deviation of the differences between the paired data values in that same sample. Okay, so some of the notation looks familiar. So again, lowercase n always stands for a sample size. In this case, it's the number of pairs in your sample. Okay, mu D stands for the mean of those differences in the entire population. Okay, then D bar is the mean of those differences from your sample. Then SD is a standard deviation of those differences from the same sample. Okay, so the null hypothesis will look like this. Okay, so you have the symbol for the mean difference for the entire population. And usually we assume the difference is 0, okay, unless otherwise stated in the problem. Okay, so mu D question mark 0, right, where the appropriate symbol will either be less than or equal to, greater than or equal to, or equal to, okay, depending on the problem. So one of these three symbols will replace the question mark in the null hypothesis. Okay, likewise, the alternative hypothesis will look like as follows, right? So the same population parameter mu D, okay, and then the question mark will be replaced by either the less than, greater than, or not equal to symbol, again, depending on the problem. And again, we assume that the mean difference is 0. Okay, so the difference between all pairs in the sample is equal to 0. Okay, unless otherwise stated in the problem. Okay, all right. So the first example we're going to look at is problem 3 in the homework. So we're going to skip the first two questions. You can answer those by reading the first page of the section. Okay, so question 3 says, a scientist claims that the pneumonia causes weight loss in mice. Okay, so this table below shows the weights in grams of 6 mice, okay, before infection, and then 2 days after infection. Okay, so at a significance level of 0.01, right, is there enough evidence to support the scientist's claim? And it says, assume the samples are random and dependent. Okay. So from the table, you can see that there were 6 mice used in this study. Okay, 1, 2, 3, 4, 5, 6. And then for each of the 6 mice, you have their before weights in the first row of the table, and then their after weights in the second row. So making these data values dependent or paired. Okay, because the before and after weights are on the same mouse. Okay. So in part A, it's asking us to identify the claim and state the null and alternative hypotheses. Okay, so the first part of the question is, what is that claim? Okay, and again, the problem says that a scientist claims that pneumonia causes weight loss in mice. Okay, so read the answer choices carefully and then select the best one. Okay, so it looks like answer choice D is the most appropriate answer. Right, pneumonia causes weight loss. Okay, and then we want to select the correct null and alternative hypotheses for this test. Okay, so before we set up the null and alternative hypotheses, okay, notice that in all of these, right, the symbol mu d is used. Okay, which is what it is we're doing. We're doing a hypothesis test on the mean difference in the entire population. Okay, but in the context of this problem, right, where the claim is that pneumonia causes weight loss in mice, right, in the context of the problem, right, mu d is the mean difference between the before weights and after weights of all mice in the population who became infected with pneumonia. And remember, the claim says that pneumonia causes weight loss in mice. Okay, so if you go back and look at the table, right, and compare the before weights to the after weights, you notice that that the before weight, okay, is larger than the after weight. So our sample data seem to support the hypothesis, right, that weight loss occurs after being infected with pneumonia. So for example, one of the mice had a weight of 21.7 before being infected, but then their weight went down to 20.3, right, 2 days after infection. Okay, so on and so forth. Okay, so basically, right, if the before weight is higher than the after weight, that means weight loss occurred. Okay, so what that means is that the difference between the before weight and after weight should be positive. So if the difference between the before weight and after weight is positive, it means that the weight loss occurred. Okay, if there's no difference, right, if the before weight and after weights are the same, there was no weight loss. Okay, but if the difference between the before weight and after weight is negative, it means the mice gained weight. It means the before weight was less than the after weight, which doesn't appear to be the case in our sample data. So how does that help us set up the null and alternative hypothesis? Okay, let's think about that for a minute. Okay, so again, the claim says that pneumonia causes weight loss. Okay, and I just told you that if the before weight is greater than the after weight, okay, that means weight loss occurred, right? So the difference between the before weight and the after weight would be positive. Okay, so a larger weight minus a smaller weight would give you a positive value, just like 7 minus 5, which is equal to 2, is a positive number. Okay, so in other words, in the alternative hypothesis, the correct symbol we would use is the greater than symbol, so the mean difference is greater than 0. Okay, so that means weight loss occurred, so the before weight was greater than the after weight, meaning that the mean difference in the entire population would be greater than 0. Okay, so then the opposite of greater than, okay, is not greater than, which is less than or equal to. So we're going to use a less than or equal to symbol in the null hypothesis. Okay, so we're going to select the answer choice that has the same setup we have here. Okay, so we want the greater than symbol in the alternative hypothesis, and then the less than or equal to symbol in the null hypothesis, right, with 0 as the difference there, the mean difference. So it looks like answer choice A. Okay. All right, then I was asking us to find the critical values for this test. So once again, we're going to use the t distribution calculator, okay, to get the critical values. All right, so just like in the previous section, right, you want to, before you find critical values for your hypothesis test, right, you want to identify whether the test is left-tailed, right-tailed, or two-tailed. Okay, notice that the greater than symbol is used in the alternative hypothesis, so this makes this a right-tailed test, right? So the pointy end of the greater than symbol is to the right. So this is automatically a right-tailed test. Okay, and also, which one of these hypotheses is the claim? Right, is it the null hypothesis or the alternative? Okay, so the claim is that pneumonia causes weight loss, which means the mean differences would be positive. Okay, So on average, right, the mice's before weight is greater than their after weight, indicating some weight loss. Okay, so the claim would be the alternative hypothesis. Okay, so with that said, we're going to find the critical values using the appropriate level of significance, which is 0.01. Okay, we also need the degrees of freedom, the correct degrees of freedom. Okay, so let's look up in the book what the degrees of freedom would be for this type of hypothesis test. Okay, and you have to read the information carefully, but it appears to say that here in this little paragraph here, when these conditions are met, the sampling distribution for the mean of the differences in the sample D bar, okay, is approximated by a t-distribution with n-1 degrees of freedom. So remember, n is the number of pairs in your data set. Okay, so in the problem, right, we have data for 6 mice. Okay, so you have 6 pairs of data, right, the before weights and the after weights. Okay, so n is equal to 6. Okay, which means the degrees of freedom is 6 minus 1. Okay, so we're going to go ahead and do this in StatCrunch. All right. So in other words, when you're asked to find the critical values for the type of hypothesis test you're going to do in section 8.3, right, you need to know the significance level of the test, okay, the degrees of freedom, okay, and whether the test is left-tailed, right-tailed, or two-tailed. So, okay, so we have all that information. Okay, so this is a right-tailed test. The level of significance was 0.01, according to the problem. Okay, and you can make a note of that as you do the homework. So 0.01 was the level of significance. And the number of pairs of data is 6. Okay, so 6 minus 1, which is equal to 5, is our degrees of freedom. So we're going to go to the stat menu, calculators, select the t-distribution calculator. Okay, select standard. Okay, since this is a left-tailed or right-tailed test. Okay, so more specifically, this is a right-tailed test. Okay, with 6 minus 1 degrees of freedom. Okay, so since this is a right-tailed test, you're going to select the greater than or equal to symbol, since it also points toward the right. And then enter, so for the right-tailed test, you're going to enter the level of significance as it is given, and then click compute. Okay, so usually the critical values are rounded to 3 decimal places. So to 3 decimal places, it would be 3.365. Okay, so that 4 there gets rounded up to a 5, so 3.365 is our... Okay, so since this is a right-tailed test, okay, it means the rejection region is in the right tail. Okay, so answer choice C is when the rejection region is in the left tail, which it's not. Okay, or answer choice B is when you have a two-tailed test. So you have 2 critical values, but answer choice A makes the most sense, where it's got the greater than symbol. And you're going to type in that critical value, so select answer choice A, and then type in the critical value in the answer box, so 3.365. Okay, and that's going to ask us to calculate the summary statistics for the paired data, so the mean of the differences, and then the standard deviation of the differences. Okay, so let's go ahead and copy the data in the StatCrunch. Or you can select open, and it will open a blank worksheet with the data pre-populated into the spreadsheet. So I'm going to go ahead and copy it. All right, and because I have the titles, I'm going to start. I'm going to select the very top where it contains a var, the name of the name of each column. Okay, so that we have the number of each mouse, their before weight, and their after weight. Okay, what we do is we go to stat, t-stats, and because we're dealing with paired data, we're going to select paired. Okay, and the sample 1 is in the before weight column, sample 2 is in the after weight column. Okay, and we can save the differences, we don't have to do that. Okay, then we select the appropriate symbols for the null alternative hypotheses, leaving these both as 0, so this would be greater than actually. If we can do a p-value plot, but that's not necessary. All right, and then the next video we'll go back and answer those the remaining questions in this problem.